Hello everyone, welcome to my channel. Myself Vignesh Anand. In this video, we are going to see about the types of synchronous motor and how they are working, and their advantage and disadvantages, then their applications. So, please refer my before video in which synchronous motor is been explained. Coming up to the topic, synchronous motor is an AC motor, whereas at a steady state, the rotation of the shaft is synchronized with the frequency of the supplied current. So the rotation period is exactly equal to the integral multiple of your AC cycles. Main thing is that it can be used for your power factor control for a low speed device, which means low speed devices, and also the speed of the synchronized motor will not depend on your load, which means it is dependent independent of your varying load, and mainly it can be controlled by your frequency of your AC source. Okay, next is your types of synchronous motor. Mainly, the synchronous motor is classified into two types. One is your non-excited synchronous motor, and second one is your direct current synchronous motor. This non-excited synchronous motor is further subdivided into three types. One is your hysteresis motor, then reluctance motor, and last is your permanent magnet synchronous motor. In that, first topic is your non-excited synchronous motor. So this motor does not require any DC supply for your rotor excitation. So instead, it uses a rotor made up of a high retentivity steel, which means your cobalt steel. During its rotation at a synchronous speed, it allows the synchronous rotating field in a different steps. Due to this, it provides a constant field in the rotor. Due to the field interaction of your stator with the rotor, it becomes a electromagnet, and it has a start north and south pole at your stator. So in this way, rotor moves according to the stator pole which is having in the stator side. Then the rotor is made up for such a high value for a magnetizing and demagnetizing, mean it has a high retentivity value. Next, coming up to the subdivision hysteresis motor. The hysteresis motor, it is a single phase motor in which the rotor is made up of ferromagnetic materials. The rotor are cylindrical in shape and have a high hysteresis loss property. So they are generally made by a chrome, cobalt steel, or a alkaline. Then the stator is which feeding a single phase supply, AC supply. So the stator has a kinds of winding. One is your main winding, and the second one is your auxiliary winding. Here the hysteresis motor is not a self-starting motor and does not need any additional windings for it. So when a single phase AC supply is given, a rotating magnetic field is produced, and that rotating magnetic field which induces the eddy current in the rotor, which means the circulating current inside the rotors, and the rotor starts to move initially with a slip. So when the rotor reaches the synchronous speed, the stator pulls the rotor into a synchronism, and so the motor will start initially as a induction motors, and later it will reaches the synchronous speed and runs as a synchronous motor. In this way, the hysteresis motor works. Next, coming up to the advantage of hysteresis motor. So as no teeth and no winding in the rotor, so there is no mechanical vibrations take place in operation. Then it operation is quite noiseless as there is no vibration, and it is suitable to accelerate inertia loads. Then multi-speed operations can be achieved easily by employing a gear trains. Next, disadvantage of hysteresis motor. The main disadvantage is that hysteresis motor has a poor output, that it is one quarter of output of your induction motor with the same dimension. Then their low efficiency and low torque. So in this case, the power factor also been very low uh, when compared with the other motors. Then this type of motor is available for a very smaller size. If the size of the equipment is getting increased, means automatically your power level, which means your power level and also your losses will get increased. So this type of hysteresis motors are mostly used in your small machines. Next, the applications, it is used in your sound producing equipment, then sound recording equipments, then for a high quality record players, then for timing devices and electric clocks and teleprinters. So these and all the common applications used for a hysteresis motor. This is the structure of your hysteresis motor. In here we have a stator and the auxiliary windings as an auxiliary winding and main winding, which is your stator part, and the rotor, which is made up of a ferromaterial, which means a ferromagnetic material, and the rotor is made up of a chrome steel. In here we have mentioned, and the air gap, which is responsible for your uh, producing magnetic field. Then the shaft and the bearings are at the between portion in order to carry out the connections and the operations. This is the total structure of your hysteresis motor. Then coming up to the next topic, reluctance motor. The reluctance motor works in a principle of a unrestrained piece of iron will move to a complete magnetic field path where the reluctance is minimum, which means the rotations which takes place by a reluctance, which means that reluctance low path. So the stator has a main winding and the auxiliary winding, just like a hysteresis motor, and this helps to create a rotating magnetic field. So the rotor of a reluctance motor is made up of a squirrel cage rotors with some teeth removed to provide the desired number of silent poles. So the reluctance become minimum when the rotor is aligned with the magnetic field of your stator. So this magnetic rotating magnetic field will be having a high efficiency in your low reluctance path. As you know that reluctance in the sense resisting the magnetic field. When a single phase AC supply is given, the motor starts as a induction motor and the rotor tries to align itself with the magnetic field of your stator and experience a reluctance torque. So this torque further dragging this rotor to place nearby the stator poles of your rotating field. Thus, it achieves the synchronous speed of your rotor by locking the revolving field of your stator part of your motor. So, uh, first it initially starts as like a induction motor, and then further this rotor will get aligned according to the stator rotating fields. So once it get tidally locked means automatically it will move towards your low reluctance path and forms a reluctant torque, and then it will moves on further with the synchronous speed. So it is mainly defined by the frequency of your supply. Then the advantage of a reluctance motor, due to its magnetic locking concept, the machine is able to produce a constant speed until or unless the any change in your uh, frequency. So if frequency get varied means automatically your rotation speed will get varied. I- it is independent of your varying loads. Then the self starting aspect of this motor makes it more robust, which means this motor is a self starting motor. Then due to a less complicated structure it requires a very less maintenance, and there is no ripple torques like a switched reluctance motor. Then coming up to the disadvantages, due to its constant speed application, no speed control is possible since the speed cannot be varied. Due to the need for both stator and rotor magnetic field, the machine is also known as a doubly excited machine, which means we needed two excitations, one for a stator and other for rotor, due to the presence of three phase winding. So the copper losses will also been higher. Next, applications. It is mostly used in common speed, which means your constant speed requiring areas. So it is mostly used in your conveyor belts and mills, and paper mills. So this is the applications of your reluctance motor. This is the basic diagram of your reluctance motor. In here, um, the main thing is that the reluctance motors construction wise also same like a hysteresis motor, so there is not much difference in between them. Then next topic is your permanent magnet synchronous motor. uh, the field is excited by a permanent magnet that generate a sinusoidal backup emf. So it contains a rotor and stator as a like a induction motor, but a permanent magnet is placed in your rotor to create a magnetic field. Hence, there is no need to wound a field winding on the rotors. So this permanent magnet will take responsible for your creating magnetic field. Then the pmsm is divided into two types. One is your surface mounted pmsm, and second one is your buried or interior pmsm. It's coming up to the working. So the working depends on the rotating magnetic field of your stator and the constant magnetic field of your rotor, because in here the rotor which is having is your permanent magnet, and it produces a constant magnetic flux and operates and locks at a synchronous speed. So when a three phase supply is given to your stator, it creates a rotating magnetic field, and the rotating magnetic field and then the constant magnetic field is induced in your permanent magnet of your rotors. So this motor operates in a synchronism with a synchronous speed. The whole working of your PMSM, which means your permanent magnet synchronous motor, depends on the air gap between the stator and the rotors. And this air gap also need to be in with no load conditions at the starting or initial stage. Then if the air gap is larger, then the winding losses of your motor will get reduced. And the permanent magnet synchronous motor are not a self-starting motor, so it is necessary to keep a variable frequency drives for your starting. Next is your applications. It is mainly used in your air conditioners and refrigerators, AC compressors, washing machines. Uh, so this and all comes in your home appliances. Then for your automatic electric power steerings, then for your machine tools like some of the drives, then for your large power system to improve your leading and lagging power factors, and from for some of the traction devices. Then for some of the industrial applications like robotics, aerospace, and for even other things. Next, we can have one example of your permanent magnet synchronous motor. So this is how the outer layer and the cross-sectional views will be there. So in inside the stator windings and the stator tools, then the rotor and the permanent magnet has been placed. So the from the outside structure itself, you can able to see the shafts and the bearing arrangement in which the load is being connected, and further conversion of electrical energy to a mechanical energy which takes place. Next, coming up to the next topic, current excited, which is your another type of your main type of your synchronous motor. It requires a DC supply for a rotor to generate a magnetic field, and it has a both stator winding as well as a rotor winding. The direct current can be applied from a separate DC source or a DC generator connected to the motor shafts, so which generates a rotating magnetic field. They can either have a cylindrical rotors or a silent pole rotors. So there are two types of rotors as used in this current excited synchronous motor. One is your cylindrical motor and cylindrical rotor, and second one is your silent pole rotors. So this is also a not self-starting uh, motors, and they need a damper winding to start. Initially they starts like a induction motor, and further it will be works like a synchronous motor. Then applications, it is mainly used in your high speed synchronous motors as such like fans, blowers, DC generators, then for a line shaft, and for your centrifugal pumps, compressors, reciprocating pumps, then for your rubber and paper mills. These are all the main applications of your current excited synchronous motors. Then this is your example of your current excited synchronous motor. In here, this mostly the construction wise also, it will be like a normal synchronous motor. It has a DC supply in which the field winding is connected and the rotor surrounding it. Then the stator, which is having a stator windings and slots and poles. Then this stator winding will be energized by a three-phase supply, which is given as a input. So in here the DC supply is given because it is not a self-starting motor. So we need a external force for it initial starting. So that's why we are using a DC supply for a current executions. So this is how the synchronous motor works. Hope you all understand. I think so. See you next video. Have a nice day. Nandri Vanakkam.